In this session, we will study about the multiplication of matrices. So, let us see. Here we have two sort of multiplication of matrices here. Number one is scalar multiplication. Multiply the scalar quantity in each element of the matrix in a matrix. Or the second one is multiplication of matrix with matrix. The number here I will explain it later. First we see the scalar multiplication here. Let us see. You have a matrix A. Where the elements are 2, -1, 5, 7, 4, 0. These are the elements we have in this matrix. We have to multiply this matrix. We have to find out, let us see, we have to find out a matrix for A. We have to multiply 4 with this matrix. It is the scalar multiplication. 4 is the scalar quantity. We have to multiply here. So what we have to do, we will put 4 here, and this again we write the same thing. 2, -1, 5, 7, 4, 0. Here you see, first I would like to explain you. This is the matrix A is the order of 2 by 3. There are 2 rows. This is the row 1. This is the row 1. This is the row 2. We have row 1 and row 2. And there are 3 columns, C1, C2, C3. So we have row and columns here. So we have 2 rows and 3 columns. It is the matrix of 2 by 3. We can multiply scalar multiplication. We could do any sort of matrix, any order of matrix. So here what we have to do now, I explain you that we have to multiply this 4 in each element of this matrix. You see in the definition I have written here, the multiply the scalar quantity in each element of matrix. So what we have to do now, explain you here again. We see 4a is equal to, now you see here, 4 multiplied by 2, 4 multiplied by -1, 4 multiplied by 5, 4 multiplied by 7, 4 multiplied by 4, and 4 multiplied by 0. So we will get this. Now you see 4a is equal to 2 times 8, 4 minus 1 times -4, 4 5 times 20, 4 7 times 28, 4 4 times 16, 4 0 times 0. So we will get this scalar multiplication of a matrix. We have multiplied matrix A by 4, so this would be the answer. Now second multiplication is a little bit typical than this. Here you see the main thing here, if we have a matrix A of order m into p and matrix B of order p into n. Here you see the number of column in matrix A and number of row in matrix B should be equal. If these both are equal, then matrix AB, the matrix multiplication of matrix A and matrix B, would be order of m into n. So this order we will get here. I explain you in number also. we have a matrix A of order 3 by 2 and another matrix B of order 2 by 4. So you see here the number of column in matrix A is 2 and number of row in matrix B is 2. So they will compensate each other and we will get matrix A B 3 by 4. So we will get the matrix AB order 3 by 4. Number of row is 3 and number of column is 4. So in this way we get the matrix multiplication. This is very specific characteristic we have to follow in the multiplication of matrix with matrix. Here you see in definition I have explained this thing. Now I explain this definition of the multiplication of matrix with matrix. I define here the number of columns in first matrix, the first matrix which we write first at the left side, must be equal to the number of rows in the second matrix. Number of rows in the second matrix. So you see number of column and number of rows in the second matrix, number of column in the first matrix, number of rows in the second matrix should be equal. So we could multiply this, otherwise we could not multiply matrices. Now we take one example for this. We have a matrix A. The elements are 2, minus 1, 0, 3, 4, 7. This is the matrix A we have, and we have the order of this matrix. You see, order of this matrix is there are 2 rows and 3 columns. So 2 by 3 is the order of this matrix. We have another matrix B. We have another matrix B. The elements are minus 1, 5, 7, 4, 3, 0. So let us see here. These are matrix. The order of this matrix is there are 3 rows and 2 columns. So 3 over 2. So you see here A matrix has order 2 by 3 and B matrix has order 3 by 2. Here we see that the number of column in matrix A is 3 and number of rows in matrix B is 3. So they will compensate each other and we will get a matrix of matrix AB of order 2 by 2. So we multiply this. Here what we have to do? We have to multiply the first row with first column with their corresponding elements. We have to multiply the element first with element first, element 2 with element 2 and element 3 with element 3. So in this way we have, I put here the name of row and column. You see this one our C1 first column. I put the name with different color. The C1, C2, C3 here. This is R1 and R2 here. The first row we have to multiply with first column. So here we put the name with different color. Here also C1 and C2 and the columns and the rows R1, R2, R3. So here the rows of first matrix and the column of second matrix. We have to multiply the corresponding elements of this. The first element with first element, then second element with second element, third element with third element. In this way we have to multiply. I explain you here. So AB matrix you see here AB matrix R1 and C1, corresponding elements of R1 and C1. So just I do some correction there. So you could easily understand this thing. This I remove from here. So here we have remained the rows of first matrix and the column of second matrix. So we have to include in multiplication the rows of first matrix and the column of second matrix. The same way, the same thing is here. So we get a formula here. I explain that formula for AB. Later I will tell you about the formula about this whole thing in algebraical form. First we see this all in numerical form, so you could easily understand. You see here 2, in the first element is 2. Sorry, the same color is there, I changed the color here now. So there is 2, and the first element of this column C1 is minus 1. 2 multiplied by minus 1. Then we have to add, okay, minus 1 multiplied by 7. Minus 1 multiplied by 7. Then we have to add 0 multiplied with 3. And this first row again we have to multiply with second column. So we will get the second element of first row here in AB. So here also 2 multiplied by 5. 2 multiplied by 5, first element with first element of this column, first element of second element of this row with the second element of this column. So plus minus 1 multiplied by 4 plus 0 multiplied by 0, the third element with third element. Here you see in the second row we have to again multiply with the first column, corresponding elements we will multiply and add it up. So 3 multiplied by minus 1 plus 4 multiplied by 7 plus 7 multiplied by 3. 3 multiplied by minus 1, 4 multiplied by 7, 7 multiplied by 3. The same way we have to do with the second row and second column here. So 3 multiplied by 5 plus 4 multiplied by 4 plus 7 multiplied by 0. So this we get here, you see here 3 with 5 here, 4 with 4 here, 7 with 0 here, we have multiplied. Now we simplify this. AB is equal to 2 multiplied with minus 1, it is minus 2, minus 1 multiplied with 7, minus 7, 0 multiplied by 3, 0. Here 2 multiplied with 5, 10, minus 1 multiplied with 4, minus 4, and 0 with 0 we will get 0. Here also in this term you see 3 multiplied by minus 1, minus 3, 4 multiplied with 7, 28, and 7 multiplied with 3, 21. Here 3 multiplied with 5, 15, 4 multiplied with 4, it is 16, and 7 with 0 we will get 0. So here you see we get this way. Further we simplify this. AB you see here at the last I change the color also. Minus 2 minus 7 it is minus 9, 10 minus 4 it is 6 now. This is 28 plus 21 it is 49, minus 3 it is 46, it is 46 now, and here 15 plus 16 is 31. So we have got this 31 here. So this is the AB matrix. You see the order of this matrix is 2 by 2. What we have seen earlier, I explained you the order we will get 2 by 2 here. So we have got the order 2 by 2. So in this way we could multiply two matrices with each other. So this is a way of multiplication of matrix with matrix again. If you have a matrix A of M into P, and there are elements, there are rows we have, the rows we have here, you see we have rows R1, R2, R3 and so on, R1, R2 and so on, Rn we have, these rows we have, and you see this is a matrix R1 to Rn, and the another matrix B we have, whose order is P into N. See here, I put the name of their column C1, C2, C3 and Cn. N columns are there and the rows are P. So what we have to do, if we look at this algebraically, if we have to find out the AB, AB would be like this. AB with the order M into N. So I explain you here. Summation of R1 into C1, the corresponding elements of R1 and C1, plus summation of R1 C2 plus summation of you see here the summation of R1 C1 plus summation of R1 R1 C2 plus so on, at the last summation of R1 Cn. The same way here, in the second row and third row we will get in the same way, summation of R2 C1, I change the color here, it is C1 plus summation of R2 C2 plus and so on up to summation of R2 Cn. The same similarly we will do this thing here. Okay, so we will get here at the last summation of Rn C1 plus summation of R2 C2 plus At the last we get summation of summation of Rn C2 plus so on, plus at the last we get summation of Rn Cn. So in this way we could multiply the matrix with matrix. The first row we have to multiply the corresponding elements in the column of second matrix in first column, and we have to add it up. Then we have to here also the same thing we have done here, the first row first, second, and these all things we have done here. So in this way we could find out the multiplication of matrix with matrix.